Hello, and thank you for joining our webinar, Cyber Attacks, 5 Security Must-Haves for Hybrid Infrastructure Gateways, presented by ZPE Systems. You can submit questions to our presenters anytime during the presentation by clicking on the question mark at the bottom of your screen, and we will address them at the end. This presentation will be recorded, and you'll receive an email containing a link to replay the webinar after the event. You can also find additional resources in the tab marked Attachments. I'd now like to welcome our speakers, Renee Newman, EU Solutions Engineering Manager with more than 20 years experience, and Karush Saraf, VP of Products and Marketing, who has worked on leadership teams at the world's top network security companies. In this webinar, Renee and Karush will cover why you need strong network security, why security has become so difficult, 5 must-haves for hybrid infrastructure gateways, what the right solutions look like, a tour of NodeGrid and ZPE Cloud, and finally, how to deploy those 5 security must-haves with NodeGrid. But before we begin, we'd like you to answer a couple quick polls. You can find these at the bottom of your screen. So please take a moment to answer the first question. According to research by IBM, how long does it take to find and contain the average cyber attack? Up to 4 months, 5 to 8 months, 9 to 12 months, or more than a year? And we'll wait another 30 seconds so that people can respond with the time delays. Okay, everyone's hopefully had a time to respond. So according to this research, the correct answer is 280 days or 9.3 months. So only 7% got that right. And that's the time it takes to find and contain the average cyber attack. So one more question, one more poll, we're going to start. And the question is, according to the same research, what is the cost of the average cyber attack? So $0 to $1 million, $1 to $3 million, $3 to $5 million, or over $5 million? And once again, we'll give everybody a minute to answer that. Okay, hopefully everyone's had a chance to answer. And you did better on this one. The answer is the cost of the average cyber attack, according to IBM research, is more than $3.8 million. So well done, everyone. Now on to our presentation, and I'm going to hand it off to Karush. Thanks, Karush. It's all yours.
All right. Thanks, everyone. Thanks, Victoria. So, you know, as the poll showed, and as the questions were asked, the average cyber attack obviously costs a lot of money, and not only has cost, but company reputation, and just loss of business and productivity are obviously why this topic is in the news, and that's perhaps much of the reason that you joined this webinar as well. Now, what I wanted to do is this topic of cybersecurity is covered quite a bit. I wanted to give you a different facet of how to look at cybersecurity, just to build on hopefully everything else that you guys have watched from a webinar perspective and also in practice. As we were even building the slides, the Kaseya ransomware attack happened, and the app updates make software that was previously secure insecure, right? So there's quite a bit of activity and issues that happen in the cyber world from, again, exchange, surveillance, colonial pipeline. So it's again nothing to be surprised about. But as the guy that has to build solutions for these types of issues, the very first question that I try to ask is, why is this problem happening? Why is it happening so much more today than before? Is it all of a sudden people are writing bad software and therefore there's just more attacks? What is it that's making this problem so difficult and expensive these days, right? And once that problem statement is defined, then it's potentially easier to tackle it, right? And so that's what this section is about. Is that why is this security problem so difficult, and what has changed such that attacks have become so much easier these days than potentially before, or even more expensive. So if we look at how a network was built, not as little as 10 years ago, right? There were offices just connected over private links, like MPLS being pretty popular, back to a data center. And so the compute, the data, the security, everything was centralized, right? And even today, a lot of companies keep it centralized because it's easier, and by putting a firewall and WAF and other types of protections in one location, that centralized infrastructure makes security easier. And the theme I'm going to go back to is this centralization. Really, what it's doing is it's reducing the attack surface that needs to be contained, right? And so, what is an attack surface? As an example, when enterprises then started to adopt SaaS and hybrid infrastructure, AWS came along and virtualized machines. So data started to then go everywhere, right? It went to cloud shares, it went to Dropbox, CDNs for application optimization and user experience. So data started to go everywhere, and then even with larger amounts of data, then people start to do edge compute, right? Move data to the edges on manufacturing floors, et cetera. So now compute moves as well. And to make sure that applications perform well, then people start using multiple links. Transit links to AWS with 4G and 5G. There's yet another one. And so now you have SD-WAN and firewalls at the edges, and a variety of different pieces of equipment that needs to be installed to protect and allow all of those systems to not only operate but also communicate effectively. And then, with the pandemic, everybody going home, that yet expanded this attack surface to laptops and social engineering because of that weakness of security. So the theme here is that because all the company resources went from a centralized location to this hybrid infrastructure approach, then the opportunities for attack became bigger, and that's what that attack surface is all about. And from a cybersecurity perspective, the attackers only need to be right once and get through the weakest point in an infrastructure. Whereas us as organizations, we need to now protect 100% of the attack surface. So if you, throughout this presentation, if you imagine your company as a 3D shape, and kind of the smallest 3D shape has 4 sides, does your organization have this 4-sided attack surface, or is it a multi-dimensional one? Hopefully it's not a sphere where it's an infinite attack surface, but that's how I like you to be thinking about what the layers of protection. The other aspect is usually when you listen to cybersecurity webinars, it's all about maybe that product that company is selling, be it authentication, inline security. But in reality, there are just many pieces of equipment that are in a network, and all of these equipment have different management systems. So there's a lot of disjointedness to operate a network, and also requires quite a few experts. So this difficulty of hybrid infrastructure, too many equipment, is really that problem statement that creates this attack surface. Now, in terms of what are the things that a company needs to look for when they are trying to address those requirements of reducing the attack surface. And I'm going to try to give you some that you wouldn't have heard in other presentations. As I mentioned, people may try to focus a lot on the actual attack surface with respect to ransomware and things of that sort, but the attack surface is a lot larger, and the opportunities for attackers is a lot bigger than one might expect. So we picked 5. There's a lot more than 5, but I think these are the 5s that these 5 will increase the requirements that you should be asking for when evaluating solutions and platforms for those solutions. So one is about it's easy to say 100% secure deployments. And so what does that mean? It basically is when you're deploying applications on servers, and especially with virtualized servers, there are a variety of other operational things that need to be considered. So it's not just about sticking a VM on a server remotely, but it's about how do you access and manage that server from a provisioning perspective. Is that provisioning process secure? And even the hardware that is sitting on, if you're putting your company application on a piece of hardware that's a server, and then the access to that server is compromised, right? Let's say it's sitting in a cage in a co-location website, in a cabinet. Now, what if somebody opens that cabinet and takes the hard drive away, right? So that's why you hear about data at rest and encryption of the drive. Many people don't do that on servers because it's difficult. How do you unlock that drive? So you find a lot of servers that are running unencrypted data at rest because it's just sitting in a cabinet and physical security is assumed. But in this example, I also talk about the actual hardware boot sequence. What if you're able to just cause the hardware to reboot, and then in the reboot process, it inserts a piece of malware that then does a man-in-the-middle attack and grabs all of the data and sends a copy to a third party. So again, these are perhaps things that you wouldn't have heard about, because the solution for this is not that easy, but it's about having a piece of hardware that really has taken care of these types of issues. And I'll talk about what it takes to address this. The second one is that, as you notice, in a hybrid infrastructure, there quite a bit of equipment, and the coordination of this is another weak point that comes in. So you can have very strong tools and threat engines, and and strong security on applications and strong authentication, but if the sequencing is not strong, then it creates disjointedness in policy. It creates that weak link that allows an attacker to get it. As an example, if a VM goes down and you want to recover it, are you actually recovering a good image, and are you able to recover it in a timely fashion? So many of the cyber attacks that organizations experience is not because they didn't have the great software, but it was because the orchestration of that all of those systems had a weak point. And just to reuse a corollary here, in software development, some of you may have heard of continuous integration, continuous development, or DevOps. So operationalizing the development, and the same thing needs to happen for infrastructure. So infrastructure operation and having a mechanism to orchestrate end-to-end without any weak points is something that we are advocating you should be looking for, and especially important in a distributed organization where compute is running at edges of the network, where any of those weak points will cause the branch to go down. And even orchestrating a VM at a branch location, maybe it's easy to bring it up, but one of the problems that I've seen a lot of people have a challenge with is licensing that VM. And so you have now infrastructure that is not in a operationalized state because it's not configured properly. So orchestrating the configuration and the entire chain is one of the things that I wanted to draw attention to. The other one is this ability to have an infrastructure that's flexible, and flexibility comes in multiple dimensions. One is, are you able to have the products that you need and insert them in the path of the traffic? So sometimes there is rigidness in the equipment or in the software, such that only certain software works with certain other software. And if one of those pieces of software is not up to par, organizations don't have a way of replacing it or upgrading it. So they just stay with that chain that works. It's more of the attitude of, if it's not broken, don't fix it. But over time, that's the weakness that then ends up getting exploited. So asking for ability to easily upgrade pieces of the solution on the fly and not just kind of be locked into a pre-approved set of solution is another piece. And so in cyber, this whole term of SASE has become a very popular term, and part of the reason is because of the flexibility that a cloud-delivered security enables. So having flexibility is quite imperative in being able to close down those attack surfaces effectively. All right, so this is another aspect that you probably haven't heard people mention in the cyber world, and it's about out-of-band management. And so what that's about is perhaps two pieces. One is that, especially if you think about remote locations, co-location hubs that a lot of people use, there are different pieces of equipment that's sitting there, from switches and routers and servers and power supplies. And the ability to be able to get to that infrastructure and do maybe three things. One is to monitor it and make sure that there are no issues with it. One is to do that in a way that is not inline, and the third one is to be able to actually have visibility 100% of the time, so that in case something happens. And let me explain that more. In the case of out-of-band, this is about an IT admin being able to get into a remote infrastructure in a way that is not the same path as the normal traffic goes through. And we find a lot of companies that have deployed equipment, but for management, right? As an example, let's say an F5 load balancer. They deploy F5 load balancer, but then they expose the management system in an out-of-band fashion, such that the IT admin's job is easy, but but the security device is not protecting that. So two aspects of out-of-band. One is that if you have out-of-band, make sure that it's secure. There's authentication. There is the implementation is a secure implementation, and then the second part is that the out-of-band should be truly out-of-band, such that if your infrastructure goes down, the out-of-band doesn't go down, right? And that's the reason that people put out-of-band, but they end up not securing it. So having a secure out-of-band where you can get to the infrastructure and the equipment behind that infrastructure is another thing that we're advocating to ensure that the security stack is and your work loads are properly running. And then, finally, this fifth one that we selected is to really have proper device security. And device security is people have agents, etc. But going down all the way to the very start of how software even engages and starts on a piece of computer, on a server, is that if the proper software is not able to start, then an attacker can come and take over that system and have it do something else, have it reroute the traffic. So having a device that starts from that certificate root of trust, and you're going to be hearing more about this with 5G, because that is one of the fundamental aspects of 5G. But having root of trust from a boot perspective, from a device identity perspective, is another piece to ensure that the layers that you put on top of that foundation can't be attacked. Now, in this next section, I'm going to talk about what does the right solution look like and the attributes that you should look for in the right solution. Again, I'm assuming that all the engines are being purchased, but it's about how do those engines run on a secure infrastructure, right? And a secure platform. So this is where you see different aspects of a ZPE solution mentioned here, where first the goal is to use a secure platform. And a good thing to imagine here is a remote branch office, let's say with a few hundred users, and you want to run a certain set of applications for firewall, for SD-WAN, but also you have workloads for, let's say, security cameras, or it's a manufacturing site that has robots running, and you want to be able to coordinate those the aspects of the solution. So there's data deduplication that needs to be running there, etc. But all of that needs to sit on a platform, again, that's secure, that can orchestrate, and then have the variety of interfaces from a 5G, from a out-of-band serial management, even USB management of devices. And so that's the stack that would have the attributes of starting these workloads securely, starting with this hardware root of trust, secure boot, encrypted disk to make sure that the data can't be lifted. All of those aspects, I would say, are important asks to ensure that any workload that you're trying to load is sitting on a platform that can't be attacked, and information can't be taken from you. The other aspect that we highlighted is orchestration, right? So looking for a platform that helps you automate the entire process, from bring up to provisioning, to service chaining, to licensing. That's another aspect, and having enough of the power to run these applications, especially with large data and machine learning applications. A dedicated CPU and dedicated storage is another aspect to look for, such that it's not just about security, but it's about the horsepower that's required to run those workloads as well. So orchestrating the workloads, but also having a platform that has enough power to accommodate that orchestration. The third part, right, and again, this is very important for a hybrid infrastructure, is to address the security risks that may be introduced because of that disjointed management, where to load a VM and to activate services some things would be automated, but some things are manual. And anytime that there's a skipped beat in this sequencing, that's again an opportunity to come in, stop the processes, or for mistakes to happen, right? So another area that these cyber attack surfaces open up is human error, right? That's quite a bit, and a lot of it is because provisioning is difficult. Then people take shortcuts, or they go around the problem, and all of a sudden they open up a port so they can license something, and then they forget to close it. And even if that port is open for a period of time, I've seen attacks come in under 60 seconds because people are just continuously scanning all IP addresses. So automation end to end with a zero-touch provisioning is an aspect that I want you to look for, and do it centrally from a cloud, so that you can say, this is the service chain that I want, push a button, and the entire process is accomplished. Easy to say, hard to do. So I want you to kind of be aware of this. It makes life a lot easier once you have it. The other aspect is this truly open solution. So if you want to run certain best-of-breed security solutions, if you want to run tools at the edge of the network, if you want to send traffic to a SASE solution, you want to be able to do all of those freely and be able to pick and choose the pieces that you want to run on this platform. So what we find is that solutions that are Linux-based, that can support guest OSs, have the standard x86 architecture, and are open to the standard orchestration software that everybody else uses. So nothing that's proprietary, but just take open orchestration that's fully vetted by the larger community. This combination of truly open is a very powerful combination to not, again, introduce these corner cases that get exploited. So we want to make sure that you look for a truly open solution as you make your selection. And then back to this out of band, right? So a reliable out of band is, the characteristics that it would have is to be able to gain access to a remote infrastructure, or let's say a co-location hub and an Equinix. You want to have the out of band be available via a variety of methods, but whichever method is available, do the multi-factor authentication, single sign-on, and be very robust in terms of role-based access control. You don't want to, once the access is gained, everything to be accessible. So that level of zero trust applied to the out-of-band infrastructure is very important. Looking for an out-of-band that if your infrastructure goes down, the out-of-band doesn't go down, so you can bring it back up again. So sometimes cyber attacks is about just denial of service, right? Where they can attack a piece of the infrastructure, the whole thing goes down, and that in itself causes an issue. And then the other aspect of out-of-band is it's about getting to the rest of the infrastructure as well, so you can revive it in case something happens, or re-image it. If you find that it's been compromised, it's very hard to revive a compromised system just by logging to it. So ability to go at the very bottom layer and reformat the entire thing and rebuild it all automated and remotely is another aspect that I want you to be looking for, and that's one of the things that we do at ZPE. So this is a summary slide of a solution that a lot of our customers, very large customers, have deployed because of all the attributes that I mentioned. So a platform that hosts the workloads, it orchestrates the entire security and connectivity service chain, rich out-of-band connectivity that can connect serially via USB, IPMI, so any which way people want to connect, 5G connectivity, rich deployment options from small to large, with rich compute capabilities and storage. All of those locations can be simply managed by ZPE Cloud. So you have hundreds, thousands of branches. In fact, one of the attributes and the reason people choose the ZPE solution is because of the ability to scale. So that's, if you're a large organization looking for scale, that is one of the key attributes that we deliver over anybody else. And at the end of the day, ability to have a single device that addresses your Wi-Fi, PoE, and builds that true SD branch solution is something that you could look for from our portfolio of products. So in the next section, I'm going to pass it to my colleague Renee, who's going to tour a few of the capabilities that we have, just to showcase some of the connectivity options and ability to run things at the edge. There are so many other capabilities that we can demo for you, and potentially we can do it in an upcoming session. But please take it away, Renee.
Thank you very much, Kurush. So welcome everybody again from my side. As Kurush already mentioned, I just will give you a short tour of the product, of the different parts, which Kurush just spoken about or has spoken about. Essentially, there are probably going to be three big parts of it. The first one is really focusing on the SASE model, security on the edge, and what can we do there. The second one is going to be looking a little bit at workloads which you can run, again with a little bit stronger focus around security, and the last one is going to look a little bit closer at the out-of-band section. So let me briefly show you what our setup is here, or what we envision, what we want to show you. For one, on the left-hand side, you can see I would say a typical edge deployment. It can be a branch, can be a small office, can be in industrial locations, or can be just an IoT location out somewhere in the field where it's really, really hard to get to. Here, what you see here is that we have two devices, two node grids in a HA pair. They provide high availability network access for the branch, for the edge locations, and for all the devices which are there, which again, it can be anything from a standard laptop, which you might have, over sensors, industrial control systems, or you just might have some basic layer 2 switches, some local on-site servers for compute or anything like it. So those two devices will provide the connectivity, and as such, they're providing some additional services to the site as well. Some of the services are provided directly by us, or in that case, by the node grid operating system. Here I'm talking about like services like DHCP, a local NTP server, and some basic security around firewall and DNS. On top of that, then we have our hypervisor, which we provide natively to our solution, and that then can provide additional services by third-party vendors. Here in our case, we have a DNS resolver, some local monitoring and Rumble, and all of that is secured back through a secure IPsec tunnel through one of our SASE vendors. Here you can see a range of different SASE vendors which we are working with, which we have validated, but it's by far not a complete list, and it's changing all the time. Essentially, all the network traffic from the site goes through the IPsec tunnels to the SASE provider, which ultimately provides the access and control and security to the site. Okay. So that briefly as an overview. Let me share my screen now. Oh, I have to click there. Okay. You should see now our login portal to our ZPE Cloud. And again, it's not going to be a full demo. For anybody who wants to see a demo or dive into some parts a little bit deeper, then just feel free to reach out to us, and we can arrange that for you. So in our ZPE Cloud, we use that to allow our customers to easily create and orchestrate their sites. And what you see here is a single site. I placed that here in Ireland. I'm personally located in Ireland. And that site has two nodes, which you can clearly see, node A and B. And I use ZPE Cloud to fully configure those devices, to deploy all the services which we just spoke about. And ZPE Cloud, beyond that, gives me access to the site, gives me access to individual end devices for out-of-band control and the orchestration parts. The same thing looks locally on the device, like the following. If you just log into the device, you see an overview again of the managed devices. You can directly see the second node. You can manage the second node from here, and you have full access and control to all the other devices. And applications, we will look at that a little bit in a short while, are one then the additional workloads. So to demonstrate a little bit the HA capabilities and the security, what I'm going to do is just going to show you a little bit in that terminal screen. What I'm going to do, I'm going to log into one target device, connect it to that branch office, and I'm just going to simulate some load which goes out to the internet and through the SaaS provider. So that is now just simulating a download. And typical, when you want to demonstrate something, it doesn't work. So that should normally simulate the download, and the download should have started. For whatever reason, that is currently not working. So then let me briefly talk through what you would normally see. Here in that graph, you would see the network throughput that is currently limited to the inbound traffic. And you would be able to see that the network traffic goes primarily through node A by default. And then in a failover scenario, it would just fail over directly to node B. I'm going to save that because there's currently nothing to see without the actual download to work. On top of that, what you would see then here at the bottom as well is log events coming from both devices, and they would clearly indicate that the device went down or went up, and the interface went down or up. Okay, so then let's switch over a little bit to the workloads. There's a little bit more to show there then. So I mentioned before that you can run multiple workloads on the system, and those workloads can be anything from a next generation firewall, which you might want to run locally on the system, or some additional security applications which make sense in the branch office. And what do I mean by that one? Now, with having the security already provided by your cloud provider, by your SASE provider, that really opens up to enable you to run additional services in your branch locations, in your edge locations. That can be anything from a basic additional monitoring tools. Here you see two sets of examples with fire and metric beats. Both are additional add-ons which are feeding into the Elasticsearch index. Or it can be something like Rumble, which provides a local inventory scanner. And I can show you briefly how that looks like. All of these systems run directly natively on the unit in form of a Docker application. But you can do the same thing with full-blown network or virtual machines as well. But coming back to the Rumble exercise or example, so Rumble provides an inventory scan of your network and can clearly identify devices which are currently available or were available on the network. And that really helps you to identify additional devices which you wouldn't expect to see on the network. Here are, for example, two examples which probably are then worthwhile investigating. One is a Raspberry Pi, not really common in normal network or enterprise environments, and are sometimes quite a favorite for, I would say, for people who might not be so well-meaning to your network, because Raspberry Pis are quite easy to operate and quite easy to hide. The other thing is, here in this case, I have a rogue wireless access point which serves out the network, and then additional clients might connect to the network and to the internet. So thinking about these kinds of additional tools, which make our platform really, really easy to deploy and to use, really enhances the visibility which you gain into the sites. And visibility is one of the key aspects of security nowadays. Essentially, if you don't know what is going on, you can't act on it, and you might miss early indications that something is amiss. The last part, which I then briefly want to show, is the out-of-band part. Karush already spoke about it. Why is out-of-band in the edge locations or remote locations so important? The traditional way is, or thinking about out-of-band is, it just provides access if something is broken. But out-of-band ultimately provides far more. For one, it provides you a secure connection which is completely independent from any production network which you have to a remote device, typically using a console cable. But even if it's based on an IP protocol like IPMI, you can ensure that you have a direct connection which doesn't go through any production switch or even management switch. So what I'm going to show you over here is, it's still the same system which wouldn't download for me. And what I'm going to do is I'm going to restart the system. And what you will see here on the right-hand side in the event logs, you will see a couple of events popping up that the device has restarted and that the BIOS was visible. Why is that important? Now, just because somebody types in reboot is probably not so important, but the capability of logging everything which comes from the device through the console interface allows us to clearly identify when the device runs through the BIOS, for example, and that could give you, or through the bootloader, that can give you a clear indication that somebody restarted the device. Now, that might be a planned change, might be a planned reboot, but it might be something unplanned, might be something malicious. Somebody might try to get, for example, into the single boot mode of the device, or might have some other ways of causing the system to reboot, to restart, and might cause outages on the device. Yeah. There's a little bit of a delay in the logs, but should pop up in a second. Okay, just updated over here. You can see already device went up, device went down, and you can see here what we call event ID 401. The alert string was detected. Essentially, what that tells me is, and if you would see the full message, that the device restarted and we saw the bootloader. Okay, so alone the visibility to know for sure that the device was restarted can tell you already something if the site behaves as it should be, or if there is just something happening which is a little bit out of the ordinary and might warrant some form of investigation. And all of that can be fully automated, quite obviously, and can directly feed into your SASE system, for example, if that can consume additional information. And all of these informations are completely independent from the device. If an attacker gets into the device through the normal network, through the management interface, and even disables the local logging, whatever is on the console interface displayed on the console system, we will track that, we will log it, and we will directly forward it. And there's nothing what the attacker can do about it because it's completely invisible to him. He doesn't know that the session is being protocoled and that whatever is displayed there is visible to your organization. And that is just, it's finishing the short walkthrough. I apologize again that the one demo didn't work. Sorry, I'm going to stop sharing now. And then we switch back to our
Thanks,
slide.
Renee. Appreciate that. Yeah, I mean, just to maybe put what was seen in context, at the last demo, especially where imagine an entire company and infrastructure that's globally distributed, even in locations that are that equipment is installed. So there's not even IT staff or even humans around, but alongside railroad tracks or at manufacturing locations that are just supposed to be operating. In all of those locations, we are able to see all of the different facets and machine log data that's coming even down from the console layer, and centralize all of that and be able to report what exactly is happening around the world, and if there's something that's abnormal taking place, as an organization, you have visibility into that. Whereas in normally all of that data not only is not looked at, it's not even collected and generally lost. So as a platform, the ability to have a secure end-to-end orchestrated deployment, as well as visibility into what that deployment looks like, and if something abnormal is happening, that is one of the areas that closes down the attack surface that would go unknown until it's exploited. So I hope that the point that we were trying to make with that demo came across, and to actually get into the details, we invite you to contact us either email or on our website to be able to see the true power of the platform. Victoria, I think we may have some questions on the line as well, right? We could switch to that. Okay,
Thank
perfect.
you, Renee and Karush. It looks like we have received a number of questions. So as a reminder, you can still submit questions at the bottom of your screen. And if we run out of time before addressing them, we will follow up via email. So I think this one might be for Renee. Does NodeGrid support VMware images?
So we directly don't support VMware images. Our operating system is based on Linux. As a base platform, essentially. Linux has its own hypervisor called KVM. So we natively support KVM. Now, they are from all major vendors. They directly support nowadays both ESX hypervisor as well as KVM natively. So in most cases, it's just a question of using a different style of image, or in many other cases, we can directly build images from existing ESXi images as well.
Great, thank you. This one, it's more of a security question. Why can't I just deploy a next-gen virtualized firewall and be done?
Maybe I can answer that one, having built those in the past many years. So the firewall does obviously a great job from a data path security. And what we are trying to do is talk about the other aspects of attack surface that need to be addressed. And so a firewall wouldn't necessarily be looking at the CLI of a machine. A firewall also can't really protect itself if it's sitting on a substrate that is weak, right? And that can really undeploy the firewall. So a firewall is great. We just want to make sure that it's all the different systems around the firewall are also as secure. And so this is our solution is complementing firewalls to make your infrastructure better, and again, reduce all of the different facets that normally people don't think about.
Great, thank you. One more question. Can you use apps from different providers like 128T, Darktrace, and Fortinet?
Maybe I'll take a piece of that one as well. So I think there are two questions there. One is in terms of applications. So if the application is has running in a container or as a KVM image, we can run it on our CPU. We also have dedicated CPUs for applications that are not necessarily for the data path monitoring. So data path to me means SD-WAN or firewall or other applications that touch the packets as is flowing through us. But other applications like the Rumble scanner that Renee was showing, or even imagine running big data application or what's called data thinning. So those are completely separate edge compute applications, and we can run them on our main CPU, but we also have the NetSR platform that has dedicated compute cards and storage cards that can run that on its own in its own space, and you get it all in one box as well. So the answer to the question is yes, and there's many different ways that we can run applications.
Great, thank you. One more question. Is there a way to get ahead of attacks and find out what weaknesses hackers can see?
Well, I think if the question is about at an organization, at the customers or at your organization, can we get ahead of those attacks? Basically, the answer is that an assessment is really what's needed there to know what infrastructure exists and assessing that attack surface. But now you see a lot of solutions that are about that. And again, it's one of the main points I wanted to leave the audience with as part of this presentation is that an attack surface is not just the pieces that you see. Imagine a shape and then the rest of it is in the dark, right? So there are the attack surface organization is not just doing an external IP scan. There are different vectors that it comes in as. So doing an assessment of where are the other portions that are not visible to the organization just yet, including the inadvertently exposed ports, including weak hardware, the passwords that have already leaked. So all of those, I think, need to be part of the assessment. And we can, please contact us. We can, have a conversation around that and help.
Great, thank you. So it looks as though that is all the time we have. We'll respond to the questions we could not get to via email, or you're welcome to reach out to us at info@zpesystems.com. Thank you again for joining today's webinar, and have a great rest of the day.